For problem number 31 in figure 11b, the switch is closed at time equals t, and the capacitor begins to charge. What is the voltage across the resistor and across the capacitor expressed as fractions of the original voltage V naught? And they ask us to round that to two significant figures just after the switch is closed, right off the bat, and then after two time constants have elapsed. And so remember that the time constant is always going to be tau, which is equal to resistance times the capacitance. We'll do that in a second. And then lastly, part C, it says after many time constants have elapsed. All right, so we got a little bit of stuff to do here. So for part A on this one, right after it's just switched, so I'm just going to make a little note, just switched. So what we're going to have is we're going to have a current, boom, we close the switch. It was open, we close it. Current starts to flow. Originally, there's not a whole lot of charge built up here. So the current comes through here. There's a resistor that has an effect on the voltage. That voltage coming out here is going to now charge the capacitor. And so what we're being asked is really three questions. What's the initial charge on the capacitor right after we drop the switch? What is it after two time constants? And what is it after it's been there for a long time? So part A is right after the switch is closed, the capacitor is not charged, right? Because we just flipped the switch. So the capacitor is not charged. And then if we want to do some math on that, well, we don't need to. Right? It's just 0. Okay. And we could also think of it like this. All right. So because the capacitor isn't charged, the overall voltage is really going to be the initial minus the capacitant voltage, right? So it's like a delta V. Okay. And so then, yeah, so it's just going to be whatever the original is at that particular point in time, because it hasn't been charged. So now for part B, what we're going to do, it says after two time constants. And so for that one, we're going, and let me write this down, 2 time constants. And so let's write the formula in for here. So now to find the voltage of the voltage across the capacitor, what we need to do is we need to figure out what the initial voltage was and multiply it by 1 minus E raised to the negative t over tau, but they gave us 2 times constants, so that's really the initial voltage times 1 minus E to the negative 2. Okay. Now there's not the, so if you crank through and you do the math, now you might, we don't know what the initial voltage is, V, but remember E is a number, right? So we could plug that in a calculator and we would get that is about 0.86 times the initial voltage. Okay. So then the total voltage would be V naught VC, which is equal to 0.14 V naught, right? Which is the complement of the voltage across the capacitor. And so now for part C, it wants to know what it would be after many time constants. Well, now after many time constants, the capacitor is really fully charged. Okay? And so if it's fully charged, then the voltage across the capacitor is now, instead of being equal to 0, it should be completely, that voltage should have transferred from the battery completely over. And so then our voltage across the resistor then will be 0. Okay? So that's part C.